Welcome to Study Loop.
This is the answer to Chapter 12, problem number 73 from the Smith Organic Chemistry textbook. And in this problem, we are asked to devise a synthesis of 3R4S34-dichlorohexane, starting from acetylene and using any needed organic compounds or inorganic reagents. Okay, so really our only restriction here is that we need to start from acetylene. And so this is going to be similar to other problems that we've seen where we're told to start from acetylene. This is basically going to be a matter of stitching the other carbons that we need onto the acetylene using a strategy of deprotonating the acetylene and then using an alkyl halide. And then once we get to there, we can reduce the alkyne that we end up with and then add our chlorines. And so the first thing we're going to do is going to be to deprotonate the acetylene with sodium hydride. So that's going to get us to acetylide ion. And so we have 2 carbons here. We need 6 carbons altogether. So we'll add 2 carbons on the right side here by using ethyl bromide. Okay, and we can repeat the exact same thing to add our 2 carbons to the other side. So again, deprotonate. This time we'll deprotonate the other side, obviously. Okay, and then again, ethyl bromide to add 2 more carbons. Okay, and I'm actually just going to switch to skeletal notation here. 1, 2, 3, 4, 5, 6. So there we go. So we have all of the carbons that we need. We can then reduce this to the trans alkene. And so to do that, we'll do a dissolving metal reduction, aka the Birch reduction. So sodium metal and ammonia, liquid ammonia. And so that's going to get us to here. And so transalkene. And then if we just were to use chlorine gas here, that's going to do an anti-addition of chlorine, which is what we are looking for. And so this is actually going to be our final product. Okay. Yeah, and so that's 3R4S34-dichlorohexane. And so again, the way to approach a synthesis problem like this is to look at what we're being told to start with and look at what we're being asked to make, and to just figure out how to get from starting material to product. And so in this case, it's adding 2 carbons to either side of the acetylene to get the hexane backbone that we need. And then a trans selective reduction of that alkyne. And then just using the fact that chlorine gas is going to do an anti-dichlorination. And so that's the answer to Chapter 12, problem number 73.